This is section 9.4. It's all about logarithmic properties in Algebra 2. So there are three log properties that you need to know. There's not a proof of them. It's just three things you need to know about logarithms. All right. The first one is if you have log base b of something plus log base b of something else. So the key here is that assuming that the bases are the same, now I'm just calling the bases b. It could be that they're both base 2. It could be that they're both base 3, base 10. It doesn't matter. If the base is the same and you're adding logarithms, then you can combine them into a single logarithm. It's still the same base, so it's still, in this case, base b. But then in order to combine them, you end up multiplying x times y. So when you have an addition of two separate logs, it turns into one logarithm of multiplication. Okay, similarly, if you have logarithms that are being subtracted, so I'll say log base b of x minus log base b of y. Again, same thing. Notice that you can't do this unless they're the same base. But probably, as you might suspect, if they're being subtracted and you want to combine them into a single log, it's still going to be the same base, but this time it's going to be division. So it would be x over y. Okay, makes sense. Addition turns into multiplication, subtraction turns into division. So, for example, I usually give kind of a true-false example that I like to give on tests or quizzes. If I said true or false as the question, log base 3 of 5 plus log base 3 of 2 equals log base 3 of 7. Is that true or false? Well, hopefully you're going to say that is false, right? Because when you add logarithms and you combine them into a single log, you don't add the 5 and the 2, but it would become log base 3 of 10. Okay? And then the third log property says if you have a logarithm, and again, it does not matter at all what the base is, of something that has an exponent. I'll say x to the n. So it might be that n is a 2. It might be log base b of x squared, or log of x cubed, or log of x to the 1/2, any exponent. So what this property says is if you want to, you can move that exponent out in front. So you could move that n out in front, being multiplied by log base b of x. So keep in mind, you can go either direction. If it's an exponent and you want, you can move it out in front. Or if it's out in front and you want, you can move it back up to be an exponent. So it just kind of depends on what's going on as to where we want it. Okay, so what we're going to do today is we're going to basically do some problems that are just practicing getting to use these logarithms. We need to get to know them forward and backward. So on the first case, notice the directions say to condense. So like on letter A, you're given these three logarithms. We want to condense them down to a single logarithm, right? Make it smaller. But then notice when you get down here to letter C, it says we want to expand. So basically we're going forward and backwards. Letter C says, hey, this is only a single logarithm. I want you to stretch it out into multiple logarithms. Okay, so let's look at letter A. Before I can consider the idea that I have addition of logarithms, I need to move the 2 up to be the exponent, and I need to move that 5 up to be the exponent, because if you'll notice up here on the properties, like on property number 1, when I combined those logarithms, there was nothing out in front of the logarithm before I combined them, right? You can't combine them if there's a number out there. So the first thing I'm going to do is move those numbers out in front, and I'll think of this as log base 3 of a squared plus log base 3 of b to the 5th. And for now, I'm just going to leave this last one alone, minus log base 3 of a plus b. It does not matter that that's an a plus b in the parentheses. It's still just part of a single logarithm. Okay? So now I'm going to focus on the fact that these first two logarithms are being added. So using the first property up there, I'm going to combine those, and I'm going to say log base 3 of a squared times b to the fifth. Okay, so that's me combining the first two, and I still have subtraction of that last log. So log base 3 of a plus b. Okay, and finally, if I want to combine this one more time, I notice that this is subtraction, which means I'm going to combine them into a single log of a fraction. So I'm going to have log base 3 of a squared b to the fifth all over a plus b. Okay, so I've simplified it all the way down to a single logarithm. I've condensed it. Okay, let's look at letter B. Kind of shrink this up a little bit out of my way. Let's look at letter B. Again, I cannot, even think about this subtraction or this addition until I move all those coefficients up to be exponents. So I'm going to move this 1/2 up. I'm going to move the 2 up, and I'm going to move that 1/2 up. Okay, so when I do that, I'm going to say log, notice there's no base, so it's an implied base 10. So log of, now when I move the 1/2 up, if I have x plus 1 to the 1/2, isn't exponent of 1/2 the same as square root? So really it's log of the square root of x plus 1 minus log of x squared plus, now when I move that 1/2 up and it becomes an exponent right there, when I simplify this part, isn't x squared to the 1/2, when you combine those exponents, wouldn't it just become like x to the first? So all I really have over there is log of x. Okay, so remember we're trying to condense. So I like to do the addition ones first. Okay, so I'm going to take this plus this, right? Those are being added, so I'll combine those. So that's going to give me log of, now I could write it in whatever order I want. I'm going to put it the x and then times the square root of x plus 1. Just, I don't know, whenever there's a single term, I like to put it in front of the square root. So that's me combining those two I've underlined in pink. I still have minus log of x squared. Okay, and then my final step, notice this is subtraction. So I'll combine them into a single log. It's going to become log of x times the square root all over x squared. Now actually on this one, I've combined them into a single log, but I could simplify on the inside. Do you see that this x would cancel out with one of those x's and just kind of leave an x? So what I'm going to have left here is log of square root of x plus 1 over x. And that's my single log, and that's kind of as simplified as I can get it. Okay, so that's when we are condensing, right? We're trying to simplify it down to a single logarithm. Okay, now let's go the other direction. Notice on letter C, it's a single logarithm. I want to stretch it out into as many logarithms as I can. Well, I'm going to start with the fraction part, right? The fact that it's a fraction means I can turn it into subtraction. Oh, by the way, I apologize. This should not be LN. It should be LOG. That's actually, LN is something we do in honors algebra 2. We're just going to call that LOG. Same thing for letter D. I know it says LN. We're just going to imagine that to be LOG. Okay. That is LOG. Okay, sorry. So now, the fact that it's a fraction, I'm going to say log of the top, which was x squared y, minus log of the bottom, which was square root of a. Okay, so that's me doing the subtraction. But then look over at that first logarithm. Do you see that that logarithm actually has multiplication? So using that first log property, I could separate that into addition. So it's going to be log of x squared plus log of y, and then I still have the subtraction of log of square root of a. So I'm stretching it out into as many logarithms as I can. And since I'm really trying to practice using all the possible properties that I can, I could think about that third property, right? And since this has a 2, I could move that down in front. Over here, I could also think about this square root of a as being a to the 1/2. And if I think of it that way, I could move that 1/2 down in front. So I'm going to end up with 2 log of x plus, can't do anything with that log of y in the middle, minus 1/2 log of a. So I think that's about as much as I can do. I've stretched it out into 3 logs, and I started with just 1. Okay, and then let's look at letter D. Again, we're expanding. I want to stretch it out. So the first thing I need to think about is, okay, that 5, what does that 5 apply to? Well, doesn't it apply to both the x and the y? So I could think of this as being the log of x to the 5th and y to the 5th, right? Okay, so now because they're being multiplied, right, x to the 5th times y to the 5th, I'm going to turn it into addition of 2 logarithms. So I'm going to say log of x to the 5th plus log of y to the 5th. And then finally, I could use that third property that says I can move those 5s down in front. And no, by now, probably a lot of you guys are looking at this and thinking, oh, I could do this all in one step. And that's perfectly fine. A lot of you will be able to do a couple steps at a time. I'm just trying to write out all the steps just to keep everybody with me. So this is going to turn into 5 log of x plus 5 log of y. And so that's as expanded as I can get it. Okay, now finally, we have a third kind of directions. Notice these directions, it doesn't say condense, it doesn't say expand, it says evaluate, okay? Evaluate means you're going to get a specific numeric answer, like the whole thing might equal 5, or the whole thing might equal 2, okay? So we want a final numeric answer. All right, now hold that thought. I'm just going to kind of go off into a little thought bubble here, and I'm going to erase this in a minute, okay? If I said, hey, what is log base 2 of 8? If I said to evaluate that, well, this is what we did in the last section, right? Evaluating a log basically means you're thinking about, remember, a log equals an exponent, so you're thinking about what would this exponent have to be on the 2 to equal 8? Well, wouldn't the exponent have to be 3, right? Because 2 to the 3rd is 8. All right. So maybe what I can do is maybe I can come up here and I can say, well, let's see if we can figure out each individual answer, and then I'll just add the first 2 and then subtract the third one. Okay, well, let's think about it. For this one, log base 2 of 6. Can you think about like we did down here? Log base 2 of what equals 6? Well, it's not 3, because that 2 to the 3rd would be 8, right? It can't be 2, because 2 squared is 4. So, in fact, there is no exponent I could put on 2 that would equal 6. Can't happen. Same thing is true here. There is no exponent I could put on 2 that would equal 20. All right, so this isn't going to work. I'm not going to be able to do them individually. All right, so why don't I use the log properties, combine them into a single log, and then see if I can evaluate. All right. So when I do that, notice they're all base 2. So I'm going to say log. Now, the first 2, since it's being added, those are going to be multiplied. So 6 times 20. And I realize that many of you can look at that and say, oh, that's just 120. That's true. But it might be easier if I don't multiply it out, if I just leave it like that for now. Because then when I think about the fact that I have subtraction for the log base 2 of 15, isn't that just going to turn this into a fraction where you have it over 15? So log base 2 of all that stuff. So isn't it going to be easier now to start crossing out? So let's see. 5 goes into both 15 and 20, right? 5 goes into 15 3 times. 5 goes into 24 times. But keep going. I can still simplify. Can't I cancel the 3 and the 6? I could say, hey, look, 3 goes into 6 2 times. So what I actually have here is log base 2 of, nothing's left on the bottom, and on top I just have 8. I guess I don't really need that parenthesis. So all of that simplified down to be log base 2 of 8. All right, can I evaluate that? Yeah, I can. What exponent goes on 2? Didn't we just say that would be 3? So all of that simplified down to be just 3. Okay, we'll look at number 2. All right, so it's only one logarithm, that's true, but when you look at this, what part of this makes this seem really hard? For most people, they would say, well, it's the 100. If that 100 just weren't there, this would be easy. All right, well, let's move that 100. It's an exponent, right? Let's move it down in front. So I've got 100 out in front of log base 4 of 16. Okay, well, look at this part. What is log base 4 of 16? Well, what exponent on the 4 equals 16? Wouldn't that just be 2? So that entire logarithm is just 2, and that's being multiplied by this 100 for a total of 200. Okay, so you'll notice in the homework there are 3 parts to the homework. You'll have one part that says condense, you'll have another part that says expand, and you'll have a third part that says evaluate. So make sure you know what you're trying to do in the homework. All right, that's section 9.4.